In lesson 4, we're going to talk about compound inequalities, so basically more than one inequality. Before we can do that, though, we have to talk a little bit about sets and what that actually means and the notation for sets. So first thing is a definition of a set. It's a collection of objects or things. The objects in the set are called the elements or the members of the set. When we're talking about a set, we have to use capital letters to actually denote the set and lowercase letters to represent the elements of the set. We use the curly brackets to enclose the elements of a set. And to show that an element is contained in a set, we use this epsilon symbol here. So for example, if I wanted to say that I have a set using capital letter, set A contains the elements 1, 2, and 3, then I could say that 2 belongs to A. So some other definitions here. A subset. We can say that A is a subset of B, which is written as A belongs to B if every element in A is also an element of B. So basically that means that everything in A is included in B. So some examples here. If the set of numbers used to count things. So the counting numbers, we've already talked about this last unit, 1, 2, 3, and so on. This is an example of an infinite set because it goes on forever. So this is an infinite set. And the dots represent going on forever, where a set of numbers 1, 2, 3, 4, 5, 6 would be a subset of the set in example 1, because 1, 2, 3, 4, 5, 6 is contained in the infinite set 1 through infinity. It's also an example of a finite set because it ends. There's an end to it, so this is a finite set. Some other definitions. The set with no members is called the empty or the null set, and we use basically like a 0 with a line through it to represent that there's nothing in it. The empty set is considered a subset of every set, though, because every set has a subset of nothing. Some other important words that we're going to use when we talk about inequalities. We're going to use the union of two sets, which is basically the key word is going to be or. So A union B means all of the elements that are either in A or in B or in both. So it's everything. Keyword is A, or for that. The intersection of two sets A and B means it's just the elements in both A and B. Think about the intersection in a road or intersection in a graph. It's where the points are in common. So it's all of the things that are in common in both sets. And the keyword for this is going to be and. So let's look at some examples here. So A union B is going to be everything. So in A or B. So you don't list repeats. So if I look at A and B, I need to be in A or B. So I have 0, I have 1, I have 2, and I have 3, and I have 7. So the union of A or B is going to be everything in A and in B. So 1, 2, 3, 0, 3, 7. I don't need to repeat the 3's. So I just do it one time. The intersection means what's in common between just those sets. So what's in common? Well, I go 1, I don't have 1 in B. I go 2, don't have 2 in B. 3, however, is in both A and B, and it's the only element that's contained in both. So that means the intersection is going to be 3. And then the intersection of A and C. So if you look at C, C is an infinite set. It's going on forever. And if you look at A, we have 1, 2, 3, which is actually contained in C. Even if A had 4 in it, I would know that 4 is going to be included in set C because set C is going on forever. So the intersection is just going to be 1, 2, and 3. Basically all of the members of A. All right, let's look at one more example with sets. So let A equal the set that has 2, 4, 6, 8, and 10, and B is going to be this new set where this piece of information is true. So the first thing is reading what this even is saying. So um, this little bar here, that is read as such that. So when you read this bar, it means such that. So x such that x belongs to A and x is less than 8. So these have to be true. So basically this new set B is going to contain all elements from A that are less than 8. So it also has to be less than 8. So basically we know that it has to be a member of A. So looking at A, find all of the numbers that are less than 8. Well, all the numbers less than 8 are 2, 4, and 6 in set A. So your set B is going to contain those 3 elements, and that's it. All right, so now going on to inequalities. So if you notice, when we're talking about a compound inequality, we're going to connect 2 or more inequalities using the words and, which is the intersection, or, which is the union. So, an inequality, first rule, an inequality statement that has 2 inequality symbols implies an and. Whenever there's 2 inequality symbols and one big inequality statement, it's going to be an and. When an and separates the 2 inequalities, we're going to shade just the overlap. So we're going to shade in between the values. When we have an or, we're going to be shading both sides. It's going to be like the ends. So let's look at some examples so you can see what this means. So this is an or situation, so we want to graph the solution set for this inequality. So I have x is less than -1. So we're going to start with, basically I'm looking at -1 and 3 are going to be my values. So let me make sure I get all of these on my number line. So I'm going to have -2, -1, 0, 1, 2, 3, and 4. You got to make sure you include these numbers. So if x is less than -1, it's going to be an open circle. My shading is going to the left because I need to be less than -1. If x is greater than or equal to 3, it's going to be a solid circle, and my shading is going to go to the right. Remember, you can look at the direction of the arrows to kind of help you with this too. So this is an or situation. My shading is on the outside of the 2 numbers. I think of it as like if you were in a boat, your oars look like paddles, right? So here's your oars or your paddles. And this is like, the middle of your boat is right in here. So we have our solution then. If I wanted to write this in interval notation, showing you how we use this with our unions, would be -infinity to -1, open bracket, or, so union, include 3 to positive infinity. So that's how you would write your solution using interval notation and unions. All right, let's look at another example. This is an and case. So and means we're going to be in the middle. So let's first of all get our number line. Let's get our numbers. So we have -2, -1, 0, all the way up to 3 we need to include. All right, so plot your points. X is greater than -2. So x is greater than -2 means it's going to be an open circle, and I'm going to be shading to the right. Now I'm not going to finish my shading all the way yet because I'm looking for the overlapping. So if you envision this up here, I know that I'd be shading to the right for that first inequality. If I look at the second inequality, I'd be starting at 3 and I'd be shading to the left. So your solution, when you're looking at this, is going to be where your 2 inequalities overlap. So my 2 inequalities overlap right in this region here. So that means my shading goes in between these two values because it's and. It's where the intersection is. So it's the intersection of both of these inequalities is right in the middle. So you don't need to show this top part here. You just really need to show on the number line. Once you know it's an and, you're going to basically fill in between those two values, the -2 and the 3. And then when you go to write your solution, it's always going to be one interval because it's going to be connected. So it's just -2 to 3. Open brackets around both because you're not including either of those values. All right, let's look at a couple more examples. So the next one, you're going to actually have to do a little bit of solving, and it's an and. So that means I expect my solution to be in the middle of my two values that I get out when I solve. So separate these and solve them. So I have 2x minus 1 is greater than or equal to 3. So let's solve that. So divide everything by 2. We get x is greater than or equal to 2. Then we're going to do the same thing for the other one. So we have -3x is greater than -12. Remember, when we divide by a negative, you got to remember to flip the sign. Always, always, always flip that sign. Don't forget. So I have x is greater than or equal to 2, x is less than 4, and this is an and situation. So that means you can be both of these things at the same time. I can be greater than or equal to 2 and less than 4 at the same time. So I'm looking for the intersection of these two inequalities. So we're going to draw our number line. So 1, 2, 3, 4, 5. Plot our points. So we have 2 is going to have a solid circle, and we're going to the right. And then x is less than 4. It's going to be an open circle, and we're going to be going to the left. So we're going to be shading in between those two values. The solution to this is going to be 2, comma 4, open bracket around 4. If you leave your solution like this over on the side with the inequalities, you have to include the word and in between them because you are saying that where these are both true. Or you just do it in interval notation with the 2 going to 4. All right, a couple more on this example here. When I look at this example, this isn't separated by the word and or, but whenever you have a situation where it's all compiled into one, we're going to basically treat it as two separate situations. So I'm just going to rewrite it, first of all, as two separate inequalities. So I just copy this part twice, and I just separate it. And it's going to be an and case because of the fact that we had our two situations compiled into one. So just solve them each. So I'm going to bring my 1 over. So I get -2 less than 2x. Divide by 2. Notice that I'm dividing by a +2. Just because this case over here, it's a -2 up top, doesn't mean I need to flip the sign. It's only when it's whatever you're dividing by, is whatever this number is down here. So I'm dividing by a +2, which means I keep the sign as is. Then I go over here, I bring the 1 over. So I have 2x less than or equal to 10. Divide everything by 2. We get x is less than or equal to 5. So